you go. All right, 5-2. Oh, wrong one. 5-2, day 2.
It's actually good. I thought I would hate it. Scary.
Back to those identities.
I thought you would hate it.
Yeah, because that's just like the third one.
You didn't like the first one.
I hated the second one because it needed to be dropped. Because I thought it should end, but it was actually really neat.
Okay, we're at the verify stage.
Can I write theta instead of X?
You can write any letter you want in there. They had S's on. I had S's to start with, and I got rid of those. Okay, so this is where they're giving us the answer. Our goal is to show that one side equals the other side. Okay? So, we work with the more complicated side to make it equal the more simplified side. So what do you consider the more complicated side here?
Cotangent.
Yeah, so what can you do with cotangent?
You can,
Sine over, no, cosine over.
Cosine over sine. And tangent is sine over cosine. Am I allowed to cancel across this add sign here?
No,
You cannot ever cancel across an add sign. All right, so I've got two fractions here. What's the only thing I can do with two fractions? Combine them, add them together. I'm going to add these two fractions. What do I need in order to add fractions together? Common denominator. So I'm going to make two fractions out of these and then bring them together as one fraction. What is my common denominator? Yep, you can multiply the two denominators together to get the common denominator. So it's sine times cosine.
You get some water, you're probably dehydrated. That is not what is wrong with me. Thank you for your when you're sick, you should be drinking water too.
Okay, so take a look. Enough? You started with sine as your denominator. What did I multiply by to get this new denominator?
Cosine.
So, if I multiply the bottom by cosine, you multiply the top by Katie. You get cosine squared. So show the hit it with a 1. I think people don't want to show much work on these, but it helps. So what do I have to multiply the second fraction by?
Sine.
I have to multiply by sine over sine.
Isn't that cosine?
Oh, yep, cosine squared.
Why is this happening?
Why is what happening?
Why are you hitting this with 1?
Because I changed the denominator. I'm trying to get to my common denominator.
So what did you do to that fraction to get a cosine?
I multiplied the two together. And I said that.
Can I make a suggestion?
Yes?
For all the examples you do from now on, can you use theta instead of X?
Oh, wow, okay. If it makes you happy.
It will.
Okay.
It really
Okay, now that you've got the two fractions with the common denominator, what's the next thing to do?
Add them.
Add them together. You make a single. The whole goal is to bring these together as one fraction instead of two separate fractions. So I bring them together as one fraction. What's in my denominator?
It's basically
Sine times cosine.
so a whole
And the numerators you just add like you've got, or subtract, whatever you have here. So it becomes cosine squared plus sine squared. Am I allowed to cancel now?
Yes.
No.
No.
Okay, you can never cancel. Remember when there's an add sign? Remember, so the add sign is like they're holding hands, so I can't chop one off without taking the other one. But can I do anything at this point?
That equals 1.
That equals 1 from your Pythagoreans. So I've got 1 over sine times cosine. Now keep your eye on the prize. What am I trying to get to?
You flip her over.
Can I break this apart so that it says secant and cosecant? How do I do that? 1 over sine times 1 over cosine. Is that a legal move on my part? To break that single fraction up into those two multiplied together?
Oh, yeah.
What's 1 over sine equal to? Cosecant. What's 1 over cosine equal to? Secant. Did I verify what I wanted to verify? Yeah, I did. I got them in the wrong order, but the order there doesn't matter because I'm multiplying.
Okay, how did you get to begin with the cosine over sine and sine over cosine?
In our notes.
Cotangent is cosine over sine. Tangent is sine over cosine. Hey, we've got several of these today.
So what's
Several examples?
Correct.
what's the end result then?
I verified it. Cosecant times secant equals secant times. My goal was to get to this. So I stopped when I got there.
Will we get problems that, like, we can't verify it, it's like not true?
If they say verify, they can be done. Okay, here's our next one. This is a verify again. Okay, I did tell you to take the more complicated side and make it equal the more simplified side. Sometimes you can work on both sides and just get them to come out equal to each other. And the reason I say that is I see these two squared functions here. And if I look at my Pythagoreans, I think I can simplify this side.
Equals 1. Wait, that's the hardest one?
Well, I would call this one the harder side, but this one does simplify. So if it's something that simplifies, I think I'd work on both sides. So if I look for secant squared minus tan squared, right here, if you rearrange this identity to say secant squared minus tan squared, what does secant squared minus tan squared equal? Equals 1. So the right-hand side simplifies to 1. So that's a legal move on my part. Okay. You're good? Okay. So, this one here. You've got options. Remember the two roads we can go down? I could get a common denominator, or I could switch these out to sines and cosines and then get common denominator after. I'm not really sure which road's going to be the quickest road, to be honest.
Flip and switch.
You want to switch everything out to sines and cosines first?
Yeah.
All right, let's see what we get. So this becomes, and I'm going to write lots of steps down, cosine over, and we might be going down the wrong road. Who knows? I don't know. What's secant equal to? 1 over sine. Oh, 1 over cosine, sorry, 1 over cosine. 1 over cosine. We're going to find out. And then sine's going to stay sine. Cosecant turns into 1 over sine. Okay, so I've got cosine divided by a fraction. How do I divide by a fraction? Multiply by the reciprocal. What am I going to have?
Nothing.
I'm going to have cosine squared, because the cosine on top is like cosine over 1. Are you okay with that? I'm going to flip this 1 over cosine over. If I flip it over, what am I going to have? Cosine over 1. So what do I get when I multiply? Cosine squared. We did the right thing. You can see you got some vision here. Now I'm going to do the same thing over here. I'm going to flip the 1 over sine over.
But
How are denominators what?
They're not a denominator.
They're not. I'm not bringing them together. I'm just working. I just simplified this one out. Now I'm just simplifying this one out. We chose not to go down the common denominator road. And I said, because common denominator road I think it would take us there. I don't know which road was shorter.
Yep, see, I chose the little less traveled side.
Oh, but look at how nice this is.
It's very nice. Thanks, Axel.
What's cosine squared plus sine squared?
1.
1. Does that equal what I had on the other side?
Yes.
1. Verified. So here we did a little bit to both sides.
Fair.
That's another way to verify. Instead of just working on one side and making it equal the other side. Sometimes you can do a little bit on both sides. All right, the last two are the tough ones.
Wait a minute.
Okay?
So the answer's 1.
Mm-hmm.
So this is
2.
basically all about the work, right?
Yes, absolutely.
Pretty much has nothing.
All
to
the
do
steps
with
have to be there. I will grade all the steps. There are no quantum leaps allowed. You get points off for quantum leaps.
So this pretty much has nothing to do with the end result.
What?
This pretty much has nothing to do with the end result.
No.
There's the answer is the question.
Yes.
Quick question. How much did it take for a trade?
Quite a bit.
Quite a bit.
Yep.
So I'm guessing.
Oh, man. Are you writing that down?
Well, no, that's just my scrap paper here I've got. Number 3. We had one very, very similar to this in the first section. Okay, there's a verify. This right-hand side is simplified. I don't really see anything I need to do there, so we're just going to take the more complicated side and make it equal the right-hand side. So what road do you want to travel? The common denominator road would be the best one. So we're going to make 2 fractions. Show lots of work.
So this is just that one side.
Yep, we're going to work on the left. So, what's my common denominator? Right, you multiply the 2 denominators together. Justin, you paying attention?
I'm ready.
2 times the sine theta by -1. Just kidding, no.
Oh, yeah, I see where you were going, but it wasn't going to make it equal anything.
Yep.
Is that eventually going to have to get boiled?
Yep. You remember. Okay, so I've got my common denominator. I've changed the denominators. The numerators are going to change. Because what I'm actually doing is I'm actually going to hit each fraction with a 1. Hit it with a 1.
So how did it get extended then?
Okay?
Okay.
You good? Why not?
Just explain it. Why is 1?
They're exactly the same. They're a common denominator.
Multiplying them or both?
Both. I'm getting this fraction to have this denominator, this fraction to have the same denominator. Common denominator. Okay. So, yes, what's your question?
What, how did that, like, why did you just get 2 all of a sudden? How did that 1?
I made a common denominator. If you were listening, I said, to get a common denominator, you take each denominator and you multiply them together.
Yeah, I just don't understand.
So I did. I wrote this one times this one as my common denominator. I wrote this one times this one as my common denominator. Now I've got to figure out the numerators.
So that always works?
Always will work.
Multiply the 2.
Yep, multiply the 2 together. That will be your common denominator. So, what I'm actually doing, if I multiply, what did I multiply this denominator by?
1 plus sign.
1 plus sign. That tells me what I have to multiply the numerator by, because I can only multiply by 1 and not change the value. So I multiply the top by 1 plus sign. Well, because I'm just multiplying by 1, and I distribute that in, what's my numerator going to be? 1 plus sign. Okay, use the same reasoning on the second one. What did the denominator get multiplied by?
1 minus sign.
1 minus sign. So what do I have to multiply the numerator by? Same thing.
Wouldn't it be 1 minus?
Yeah, that's what we said.
You said, she just said the same thing.
Oh, and I asked her, what about the top? And she said the same thing. the top gets multiplied by the same thing as the bottom. Okay. You cannot cancel them out because then you'd be right back to the original problem. Yeah, you'd be right back to where you started. That happens a lot in these problems. Okay, why do we get a common denominator? What's the whole goal next?
Add them together.
To bring them together as a single fraction. Your next line, I should see one fraction instead of two.
It all equals 1. No, it equals 2.
Okay? Why am I doing that?
Oh.
I'm going to show you with numbers. Do you see it? I can show you with numbers, because if I show you a little 7th grade number one, you're going to say, oh yeah, I see it.
Oh, I was thinking of.
No, once you get the common denominator, your goal is to write a single fraction after that. Now I just add my numerators. I've got a 1 plus sign, plus another 1 minus sign. Now at this point, you want to simplify the numerator and FOIL out the denominator and simplify that. So, big fraction again. What's my numerator? 2. That's nice because I need a 2 in my verify.
What? Oh, I see.
1 plus 1.
Oh, and then
Sign minus sign's gone. Okay, we're going to FOIL the bottom because this will always simplify. So let's FOIL the bottom. And I'm going to do it actually right here. 1 times 1 is 1.
First.
Outer is going to be a plus sign. Inside is going to be a minus sign. And then last times last is a minus sign squared. Signs cancel, so I've got 1 minus sign squared.
Ooh, that's what we're,
Oh, that looks awful familiar.
no.
That looks awful familiar.
Squared. Ooh, that probably equals, secant squared.
It does not equal secant squared.
Right, it equals
1 minus sine squared. Oh, let me take a look. Here's a cosine squared plus sine squared. If I subtract the sine squared, I'd have 1 minus sine squared. What does 1 minus sine squared equal? Cosine squared. So the bottom is actually cosine squared. Almost. Does it equal 2 secant squared? Is it close to that?
I'm going to guess it's what's on the other side of the...
So
It
we
is.
flipped the cosine, right, and then we got the...
Because what we actually have here,
And then we win.
I will show you where it's coming from, but I would be fine with you saying that this equals 2 secant squared because it's 2 times 1 over cosine squared. What's 1 over cosine squared equal? Secant squared.
Yay, we won.
Yeah. Because this is 2's on the top, I'm just going to pull it off, multiplying. And when I do that, I leave a 1 in its place. It's the same thing as I had, just kind of separated it out. 2 over 1 times 1 over cosine. So you could see the 1 over cosine squared,
Why are you multiplying this and this?
because there's a 2 there in the problem, I can't throw it away.
You're welcome. Bottom purple.
You got to carry it along.
Oh, let's be true.
It doesn't disappear. It's still there.
In the elementary
You're
journal.
multiplying 2 times the cosine squared?
Yep. Times the 1 over cosine squared.
You're like all over my feet.
See, when I took the 2 off of the numerator, there's a 1 left in its place. You can. I did it.
Did you do that with anything?
Mhm. I don't know. We'll see. All right.
Don't get it. $15. High-low, coral, gold.
A high-low.
Yep.
I showed Lexi. What? About the skirt. Oh, the skirt.
Sorry. I showed my sister. She can verify. What's not funny? No. Oh, for a wear on the house on a lazy day. On a lazy day? That's something.
Okay, this one's tricky.
Yes.
Yes. Okay, on one side I've got cotangents, on the other side I have tangents. And we know there's a direct relationship there. And as far as which side's more complicated, I think they're equally the same in terms of complicated looking. So it doesn't matter whether we work on the right or the left.
Let's work on the right.
Let's work on the right. So that means I want to get rid of tangents and see cotangents because I know my answer is going to have cotangents in it. So we'll work on the right. Let's leave the 1. What can I do with tangent so that I see cotangents?
Put it over 1.
So what's it going to be? 1 over a cotangent?
I don't like working on the right side.
Okay. Now I at least have cotangents. But what I've got happening now is I've got a fraction in my numerator. So I want to make this 1 over 1. So I've got a fraction plus a fraction, do the same thing in the denominator.
Oh, this is stupid.
Okay, so forget about the denominator for now. I'm going to cover that up. Forget about the denominator. I would like to add these together. What do I need in order to add those together? Common denominator. So I want 2 fractions. This is just an equals. I kind of extended that a little bit. Okay, what's my common denominator here? Cotangent.
It's going to be cotangent over cotangent, which is still going to be 1. Wow,
I don't think we did this one right.
We did.
It did, what I just said, was that right?
I am getting a common, forget there's anything under here. I want to add these 2 fractions together. If I want to add fractions together, I need a common denominator.
So it's gonna...
So, I had a denominator of 1. I now had a cotangent. So what did I have to multiply top by?
Oh, it's cotangent over 2 cotangent. Stop!
So, this first numerator will now turn into cotangent. See, because you can see you've got cotangent over cotangent. That's equal to the 1 over 1 that I had. This one, what do I multiply by? Nothing. A 1 if you want to, but nothing.
So we just kind of turn the 1 into cotangent over cotangent.
So, why did I get a common denominator here? What's the goal next?
Make them 1.
Make them a single fraction. What will my single fraction be here?
Cotangent plus 1 over cotangent. 1 over cotangent squared.
No.
Cotangent plus 1 over cotangent.
Yep, remember the common denominator never changes. You just bring them together over that denominator. Can I write it up and not confuse anybody? Can I go upwards here? Because I ran out of room.
You would write it sideways though.
If you add
Cotangent is my common denominator. And I've got cotangent plus 1.
I'm done. Yeah, I'm going with some.
Okay, so there's my top fraction for now. Ooh, look, I got a cotangent plus 1 in it, and I wanted a cotangent plus 1. So we're probably on the right track. Yes, there's a denominator there, but I'm not done with this problem.
So that's just the end of...
That's just the numerator brought together as a single fraction. Okay, now I'm going to pretend I don't even have that top. Oh, there we go, I got a bottom.
Alright,
So the total top is cotangent plus 1 over cotangent? Why wouldn't it be the other way around? Or why, cause isn't it like cotangent over 2 cotangent? Like, you know, like, when you...
Stop for a second. If you had 2/5 plus 3/5. Nope, 2/5 plus 1/5.
Hey, then you're
Oh, I got it.
What would you do with those fractions? 2/5 plus 1/5. What would you do?
3/5.
3. You only add the numerators over the common denominator. It's the same thing with trig functions. You add the top two over, the denominator never changes when you add.
Update from NASA.
Okay, let's do the same process with the bottom.
Alright.
What's my common denominator here? So I'm going to make two fractions with a subtraction in the middle of them. I want them over cotangent. What's my first numerator going to be? Yes.
Well, I mean, he'll get.
What's my second numerator going to be?
Just one.
Just 1,
So it's the same thing, Lexi?
with a minus in the middle. This one's got a subtract here. The other one had an add. Okay, I've got my common denominator on my two fractions. What's next?
Now,
Simplify.
You bring them together and make one fraction out of the two. I'm going to do it right here. What's my denominator? Cotangent.
you always can be.
Then I've got cotangent minus 1 as my numerator.
That was stressful.
Okay, we're almost there. Yep. So,
Oh, no.
right now, I've got this fraction divided by this fraction. Multiplied by the reciprocal. A fraction divided by a fraction. So I'm going to keep the top fraction. Cotangent plus 1 over cotangent. I'm going to flip the bottom one over.
Bless you. Bless your soul.
Yep. And what can I cancel?
Oh, jeez.
That doesn't equal 1.
Keep your eye on the prize. What did I want to get to?
Cotangent plus 1 over cotangent minus.
Oh, and look at what I have.
Oh, we got it.
We got it.
Yeah, because there was a
That was a lot of
right?
the crap all shown there.
Are we done?
We're done.
Wait.
Okay, you get to try some of these on your own. Yes. What part didn't you get? Guys, you need to stop talking. This was the numerator. This whole fraction was the numerator, was this. This was this. So I've got this fraction divided by this bottom fraction.
When you go down to the bottom, you have the numerator.
I've got this fraction, I kept it the same, cotangent plus 1 over cotangent, multiplied by this one flipped over, the reciprocal of this one.
Okay, so what's the point of this?
This actually equals what I tried to get, verified it. It equals the left-hand side now, I'm done.
I just don't get because we start and then we go like in a loop
Mhm.
and go right back where we started.
Yep, that's what verify is.
That's what we're supposed to.
Yes.
Wait, go back down to the bottom. Can you freaking make more colony? I'm sorry. Okay, the only reason I was so confused on that one was because I wrote down the wrong question. I put cosine instead of cotangent.
I just don't get why we have to go in circles.
You've got 6 to try on your own.
Oh, sure. This is homework, right?
Mm-hmm. That is your homework.
Saying blush you actually means Jupiter blue bird.